Today, I'm going to mix some sulfuric acid with Epsom salts. This process produces dilute and impure sulfuric acid, but it can surely be purified simply by distillation. To break your expectation, the acid produced by this method isn't the most efficient. This video is just for showing you how you can make sulfuric acid if you can't buy it, and for exploring the chemistry road. This process is very simple, and you just need two ingredients, Epsom salts and oxalic acid. Both of them are very easy to buy because Epsom salt is used in gardening, while oxalic acid is a rust remover. To make the acid, we need 36.1 grams of anhydrous magnesium sulfate. If you are using Epsom salts, you have to use 74 grams. And we need 37.8 grams of oxalic acid dihydrate. If you want more sulfuric acid or less acid, you can just multiply the amount of the two ingredients. Just remember to keep the ratio of them constant. On the left, we have our oxalic acid solution. I have used hot water to dissolve the oxalic acid solid. Here it is, about 150 milliliters of the solution. After that, warm water is used to dissolve the sulfate. I'm using warm water because the solution will get hot when anhydrous magnesium sulfate dissolves. If you are using Epsom salt, I suggest using hot water. So now, give the solution a good shake to dissolve all the solid. If needed, you can add more water. In the end, we are ended with 150 milliliters of oxalic acid solution and 350 milliliters of magnesium sulfate solution. You can see that the sulfate solution is quite cloudy, and I think the precipitates are actually impurities. Of course, it is because I am using a product of China. Then the two solutions are mixed. I am pouring the sulfate solution into the oxalic acid solution, but the priority isn't really that important. Well, you can see that there is no change at all. What we are wanting is a double displacement reaction. In the solution, we mainly have hydrogen ions, sulfate ions, magnesium ions, and oxalate ions. In low temperatures, since the solubility of magnesium oxalate is low, magnesium ions meet the oxalic ions to form magnesium oxalate, which is a solid and is precipitated out of the solution. But why there is no reaction at all? In fact, that's because our solution is quite hot now, so the solubility of the magnesium oxalate is relatively high. In order to kick it out, we have to put the solution in the refrigerator to lower its solubility in water. Okay, let's skip ahead. And here is our solution. Now it is being decanted. You can see that the solution drink is completely colorless, and that's our dilute sulfuric acid, contaminated by magnesium and oxalate ions. So, as you can see, the solution in the bottom is quite cloudy. The precipitates are magnesium oxalates. If you mind, you can stop decanting the solution before any precipitate comes out of the beaker. In my case, I didn't because I will distill the acid. And I poured the cloudy solution into another beaker, just as to show you how dirty the residue solution is. And we are left with some flaky white solids of magnesium oxalate. Sorry for my hand, but I hope you can see that it is very brittle. So, on the right side, we have our product, dilute sulfuric acid. I will show you how to purify it by distillation in an upcoming video. If you like this video, remember to subscribe, like, comment, and share it with your friends. Thanks for watching.